Welcome to ICS Arabia. Glad to have David with us today. What's up, David? Hi.
Hey, yeah, thanks for having me. Happy to be here.
Yeah, you're welcome, and thank you for joining us. Today, we're going to talk with David. I'm sure most of you OT community know David. He's famous with his test bed, the lab, Fortiphyd. And it's an opportunity now to discover what's the latest with this lab and what's he's been doing in the last time. So, David, maybe some of ICS Arabia subscribers don't know you, especially from the Middle East. Could you please introduce yourself and when did you start or what did you do?
Yeah, sure. So my name is David Formby, co-founder of Fortiphyd Logic. I first got into ICS stuff, I guess, kind of back in my undergrad degree was in computer engineering. I took had a course on linear control systems, had a couple of internships at a Department of Energy site near my hometown. So we got to tour some of the nuclear facilities there. I did not really do anything controls related there, more computer science, basic stuff. And our senior project was robotics related. But I didn't get into security aspects of it until I came to Georgia Tech for grad school. I took my first regular network security course there, and it by far is the most favorite course I'd ever taken, like the funnest, most interesting course I'd ever taken. And I was there to get a PhD in electrical and computer engineering. And the professor who taught that network security course was trying to find grad students to help do to start doing some SCADA ICS security research. And so I, through that connection, I did really well in his class. So he accepted me into his research projects. And so did my entire PhD there at Georgia Tech, focused on ICS and SCADA security. So a few different things there, just analyzing network traffic from power grid networks, developing some interesting intrusion detection techniques, like looking at the physical actuation time of valves and relays and stuff to do intrusion detection. Then looking at PLC scan cycle times for intrusion detection. And then kind of towards the end of my time there, we were involved in a project from the National Science Foundation where we were interviewing, going out and interviewing all these ICS operators and customers because we thought we had our intrusion detection techniques could be commercialized into a product to help secure SCADA ICS networks. And we got funding to go out and interview potential customers, see like what they cared about. And through those interviews, we interviewed over 100 people, different sectors in ICS. And kind of the biggest takeaway back then, this was all the way back in like 2016. So there hadn't been that many high profile attacks yet. There was Stuxnet, of course, back in 2010. And then there was the Ukrainian power grid attack, but not that many ICS security stuff wasn't that popular. And over again, like the impression we were getting from the potential customers was they didn't realize how bad their security was, and they weren't viewing it as a real threat yet. And so that motivated the Grfics project, the building like a nice visual, easy test bed to demonstrate how the potential consequences of an ICS attack, and combine that with personal experience that I had, how hard it was to get my hands on like real PLCs, real protocols, and wanting to bring all that together into an easier to use way for people getting into ICS security. So yeah, that's kind of the origin of the Grfics project. That was the first version. I think was released in it was 2017 or 2018. It's now on the third version, which I'll do a live demo later today. And that's kind of the focus of Fortiphyd, the company that I run, is developing more simulations like that, posted in the cloud for people, or even more detailed simulations like a full cyber range larger scale simulations of Summons Network. So yeah, that's the kind of short version. Yeah.
Okay, cool. So you are Dr. David now. So
yeah, so I finished my PhD. So it is Dr. David. Yeah.
Yes, in computer engineering, right?
Yeah, computer engineering is technically the degree is computer engineering, electrical and computer engineering, but the focus was on like ICS security stuff. Yeah.
All right, so that was interesting. So you did your research on ICS as well.
Exactly. Nice. Yeah. Finding vulnerabilities, finding new ways to help detect attacks, and yeah.
So we have something in common because my PhD was on ICS as well, but
yeah,
it was on security like metrics. You know, I was trying to develop something alternative to CVSS. So just for ICS, yes.
Yeah, that's important. Yeah, because it is so different. The regular CVSS scores don't really do ICS justice. So it's a good topic.
And they brought up this topic in S4. I think I saw one or a couple of the guests. They talked about alternatives.
I think I've seen a couple talks on it. Most recently, I think the big talk this past year was on like the impact score for overall, like after an attack, measuring like what the impact is for that attack. But yeah, I think I've seen some other talks in previous years on CVSS alternatives. Yeah.
It was funny because I thought I'm the only one who was thinking about this. It was 7-8 years ago, but when I googled, I found the same people. People thinking thinking similar to me. I said, "Wow, this is amazing." When you think about an idea, and you discover some other people on the other side of the world doing the same thing and thinking. So it was wow. I never met them. I never read the papers or work, but. It was interesting to find how amazing so many people on the other side of the world think the same as you. So
it shows that it's a real problem. So many other people are thinking about it. I mean, it's a real problem that needs to be solved.
Yes, and this is a kind of problem for research because if your topic is not original, sometimes they will ask you, are you sure your work is original? Maybe you took it from these people, but I justified my work that I didn't start. I started before I saw those. So it was okay.
Yeah, those academic reviewers.
Yes,
there's a reason I didn't stay in academia. I did not like having to deal with those academic reviewers.
It's a different game, huh?
Yep.
Yeah. All right. So you've built the lab because you were trying to convey an idea to the people to be aware that there are risks, and that was the just motivation of the lab.
So it's like half helping it visually see what potential risks are for how vulnerable these like ICS networks are, and then also making it easier to get the hands-on experience to show how easy it is to attack things. So yeah, that was the original motivation, and the original project was a set of like 5 or so VMs. This is before containerization was really big. So it was a set of full VMs, and so like it still a bit of work to get all that set up, but compared to having to buy a bunch of physical equipment and set it all up, still a big difference. And then the second version updated some of the software, updated the visualization was the main thing, but it was still a bunch of VMs, so still kind of a pain to set up. And then finally, the most recent version is fully containerized, so it's much easier to set up, much lighter weight for your resources. And also one of the fun things we added in this version was instead of just a static view of the chemical process, we actually built out like an entire warehouse that you can virtually walk around, and so helping like for again trying to reach those IT people who have never stepped foot in a physical ICS facility before, giving them this, they can virtually step foot in a chemical warehouse, chemical plant, and kind of see some of the kinds of things that you would see in a real environment. So it's not just completely abstract. It's not just something that they've never experienced before.
So it's like immersion, like a game.
Yeah, basically. Yeah, and I got to show that in the live demo today when we get to that too.
But this requires a lot of maybe graphical design or graphical coding.
Some. Yeah, we use a popular like video game engine. So like there's lots of tools out there for people to build video games with, and so we leverage those to make it to build out the virtual environment.
And you have a team for this kind of work, right? Or did you do it yourself?
No, so definitely a team. So yeah, a team of people, like different, like one person specialty is more on the graphics, the visual side, for example, and then other specialty more on the back end networking side of things. Yeah, and what we we have currently just one free open source as the chemical plant warehouse, and then we have other paid. With a paid subscription, you get access to a bunch of other scenarios that we built, covering different sectors.
All right. So, would you like to go and maybe show us a demo?
Yeah,
please?
Sure.
Thank you. Okay.
Yep. So it's still running. So the command is just a simple Docker compose up. The full source is all available on GitHub. So it is completely open source. So you can look in and make modifications yourself if you want. And the instructions to download it are all on the GitHub page as well. But if you're not modifying the source, super easy. All you do is grab the Docker compose file with that curl command, and then Docker compose pull to pull down the images, Docker compose up to spin all the images up.
Okay.
So this is the main view. This also kind of one of the big changes we made in the most recent version was adding like more of a dashboard to make it easier to access everything instead of having to poke around, find individual pieces. But here in the dashboard, the main view is the real process simulation. So like eventually you pull up the operator HMI, you pull up the simulation, and you can launch a man-in-the-middle attack, modifying values on the HMI, faking out values on the HMI, while you can at the same time look at the actual real process and see that you're successfully saying the pressure's fine, everything's fine on the HMI, but in reality the reactor is like blowing up, for example, in the real simulation. And then we give easy access to a Kali attacker machine to poke around, do it kind of manually, poking around, doing different scans or attacks. For example, we have a defender machine for like programming the PLC. Of course, it's using OpenPLC for the PLC side of things. So you can open up the PLC program that is controlling this chemical process and practice your PLC programming.
Wow.
They released the author of OpenPLC released a new version just like a couple months ago that looks way better than this current version of OpenPLC. So we definitely have plans to update the OpenPLC editor and runtime environment to match his new version. And then we also added Caldera. So Caldera is a tool from MITRE for adversary emulation. So basically, it's a nice way to automate attacks against the network using like a multi-step attack using agents with different abilities, both on like IT security type stuff, as well as they have OT security plugins. Built into this lab, we have the Modbus plugin. There's other protocols that you can install separately, but for this lab, it's just Modbus. So we have the Modbus plugin. So it automates the ability to like read registers, read coils, fuzz coils. We actually they didn't have this function code before. We added this into the Caldera repo for reading device information. So like enumerating devices, seeing what the vendor and model and serial number is and all that. So it's a little bit too much to demo in a short like hour demo. You have to set up an agent and then run through the abilities, but just to kind of show you what's possible there is you can use any of those abilities to target some of the stuff in the lab.
Yeah, Caldera is kind of looks cool. I mean, I haven't tried it yet, but I've read about it. So
yeah, it's I haven't used it that much because it's a little there's a learning curve to figure out how to use it. It's a little complex and takes a while to understand. But once you learn how to use it, it's super powerful. It can do a lot of stuff.
Yeah, they just released last week or before a simulator for it. I can't remember what it is.
Yeah, I noticed. Yeah, they have like a hydro.
HVAC. Was it HVAC system? Yeah. Was it HVAC or water maybe?
Yeah, yes. I think that the most recent one was water. And they have at least one other that I think is like hydro facility or something.
Nice. So is this lab free to get to access, or it's paid? This lab?
Yeah, this one is completely free and open source. So anybody can download this. So again, like the instructions here on GitHub. Anybody can download it, use it for free. There's no limitations. It's just the GPL version 3 license, so completely free.
Version 3.
Yep.
So what's the main difference between this one and the previous ones? What's the major differences?
Yeah, so the major difference is moving from a bunch of virtual machines, so that it can be kind of a pain to set up a bunch of virtual machines. This is fully containerized. It's all Docker containers, and then adding Caldera is another nice little feature. And then also one of the main other differences is being able to walk around the warehouse. So it's I think my laptop may have a little trouble rendering this and doing the screen share. Gets a little slow and laggy.
I can see it.
Yeah. So it gives we built out a full warehouse to kind of illustrate some basic things that especially people coming from IT may not be able to experience in other ways. So for example, you can walk up to the reactor. You can see descriptions of what different pieces are, the reactor vessel versus the valves or the tanks. If you look closely at the valves, we made it kind of transparent, and you can see it's a ball valve. And so again, for IT people who have never seen a real valve in person before, we kind of visualized how a ball valve works, and you can see how it either stops the flow of fluid or gas coming through the pipe, or opens it depending on the position. And then we also kind of illustrated, if you see in the top left of the screen, it says 0 out of 9 vulnerabilities found. We kind of planted like poor security practices, like poor cyber hygiene things throughout the warehouse. For example, the PLC cabinet door is wide open and unlocked, so that's not good security practice. We have.
So you found it, and now it's 2. Okay, now it's updated.
Yeah, now it counts up as you walk around and find them. It counts up to track whether or not you found them. And then, of course, there's several different sticky notes with passwords on them that you can find as you walk around. So this one looks like it's the PLC password. This is a kind of a safety thing, but a kind of availability thing. Having a source of water right next to the control cabinet's probably not good. Then we have like a rogue access point, someone setting up a router on the plant floor, potentially opening up a new pathway into the network. We also illustrate not just the vulnerability side of things, but like a e-stop. So here's a very simple little HMI thing here showing the pressure of the reactor. We also illustrate, built into the simulation, completely out of band of the PLC, is you can hit the e-stop and then it shuts down the process basically, and you have to completely reset the process to get things going again. But you see that's it's cut off all the inputs on the left side. It's opened up the purge valve. It's opened up the product to drain out the reactor. And so it helps teach some of the safety engineering side of things of, even if the PLC is completely compromised and an attacker has written a malicious program to it, if the system is designed well, you can always physically walk up to the e-stop and hit that to shut things down safely.
Okay, nice. So it's like you're teaching who's practicing this the mentality how to assess things while he is in the
exactly, like a physical walkthrough for cyber hygiene issues as well. Yeah.
And when you switch it off, did it affect the open PLC as well at the same time, or
so the emergency stop is completely out of band from the PLC, so it doesn't. So even if the attacker has completely compromised the open PLC, has written their own program that is malicious, the e-stop is like a separate. It connects separately to the valves and overrides the PLC to kind of illustrate that safety aspect.
Nice. And is there like more than simulation, or just this simulation? Or
it's just this chemical plant simulation for the open source version.
And what about the paid version? There are more simulations, or
so for paid subscriptions, you get access to all of our simulations, and I think we're up to like about 8 or so. So a couple in the power sector, a couple like maritime ports and ships, server room, like a building automation type stuff.
Maritime, interesting.
Yeah.
I've seen you interested too much in the last few months in maritime. You were always writing about it. What's up with the maritime?
So we were. That was just our most recent new courses, new simulations. Was in maritime. So that was just a major sector that not really any other training was out there for it, and it's a very big sector within ICS. And there's a lot of interesting stuff happening, like with the Russian ghost fleets, like spoofing AIS data. Is kind of very timely, and so we as we created our the maritime simulations, we created a simulation course for port security as well as ship security, and so we're posting stuff on LinkedIn, like as we were creating the courses and as we were creating the simulations, some of the stuff that we were finding interesting and building.
Nice. Yeah. Yeah, I noticed you were like regularly posting about it. I said, "What's going on with the maritime?" You know, I was curious to know.
Yeah, it's a big big sector, and yeah, we're trying to be better about posting stuff on LinkedIn to kind of advertise what we're working on. So that was
Okay. So what's this room?
so yeah, this is the control room.
The control room. Okay,
Yeah, so yeah, of course, another sticky note with another password. The HMI is on the screen for the operators, and the Open PLC interface is up there, and the PLC program too. And so to get into the control room, it was locked, but there was a key card laying on the table that someone had left there, and you could pick that up. And once you pick that up, you can get through the door. Just to illustrate, another cyber hygiene issue of, yeah, it's good to walk the control room, have key card access to the control room. There were other sensitive areas, but don't leave your key cards just laying out. Okay. And then go ahead.
So it's a gamification and quest. It's really
kind of, yeah. Basically, we a little bit gamifying it, letting you with the tracker, making sure you find you can explore the entire plant and find all the other all the issues. So yeah, so I guess just finishing up all the issues. One other thing here is secure disposal of sensitive information. So you can find a secret recipe in the trash can there. No, someone didn't shred it. Someone propped open this door to the business side of things. It's a common thing that people do, propping open doors to secure areas, of course. And then the last vulnerability in here is just another sticky note. Walk over to the workstation and you see another password sticky note.
Okay, so I mean, if somebody is looking for a walkthrough for this kind of lab, maybe he should watch our this episode to get the solutions.
Yeah.
Live walkthrough by David himself. Yeah.
Yeah.
Okay. Interesting. Yeah, it looks nice. Very nice. And nice job, I mean, for the graphics.
Mm-hmm.
Okay. And yeah, go ahead.
Oh, I guess, yeah, remembering a couple other things to show. We never looked at the HMI and then also the router. So it is two different network segments, the ICS, the control network, and then a DMZ. And we have a router firewall between it, so you can practice writing the firewall rules. You can practice. Also has built-in Suricata, so you can write IDS rules to detect different attacks.
So here you can practice protection and offensive as well. Defensive and
exactly. Offensive. Yeah, so it's not just attacking; it also is to practice defenses. And so, like in all of our courses, we typically the way most of our courses are set up is we walk users through how to attack system, just to show how vulnerable it is, how easy it is to attack, and then we walk them through different defenses that they can do to mitigate that attack, and then they can try again and see how the attack is either blocked or it is detected. It raises alerts, so you get to see how it all works together. The HMI in here is SCADA LTS, so it's an open source SCADA software.
Yep.
Has HMI functionality and some basic like historian functionality.
Mm-hmm. Nice. 10 East. Okay.
So there's all the points that is monitoring on the PLC. And then switching to the graphical view, we see the the operator's HMI. So I've already pulled the e-stop, so things are fully shut down now. So you can see the pressure is completely is really low now. And clicking the button now doesn't do anything really, because we already pulled the e-stop, so it doesn't affect that.
So you have to walk back to the room and start it again, huh?
Yeah. So actually, I think for right now, you just have to restart the simulation to reset the e-stop, reset the process, which is quick. It's easy to do, but there's no way to walk around and do it within the simulation right now.
I see.
And then just to show off the router real quick, I think it's 200. So yeah, this is a completely custom built firewall ideas kind of packaged together for the Docker container, because there's not really any other options for Dockerized firewalls and stuff. So super simple, because we had to build it from scratch. Very, very simple interface to add rules either on the incoming, the WAN being the DMZ, the LAN being the control network. Just very, very simple rules for source and destination, ports, dropping it or allowing it. And then
it works, huh? If you implement them, they work.
Yeah. So yeah, I mean, it's fully functional. It works. Yeah. So yeah, you can right now by default it's wide open. That's so you can illustrate attacks with the wide open firewall, but we could instead add firewall rules to block to completely block off the DMZ, or to only allow Modbus traffic coming from the HMI going directly to the PLC, that's probably best practice. For least whitelisting what should come through.
All right. And
and then we have the IDS. So Suricata is running built into the router. And so the interface is kind of inspired by the pfSense Suricata interface. So you can copy and paste your custom Suricata rules into this big text block. And then I have to make sure you save it. And then once you do that, you can start testing your alerts and see them populate here in the logs.
Nice. All right. Cool. Cool. What about the host and the IPs? How somebody can tell if this is the IP of the router and this is the? Do you have
the documentation for how to access all that is back in the GitHub. Go down to this table here.
There they are.
So the dashboard. So the dashboard, we kind of intentionally only gave you access directly to like the attacker and the defender, and then we want to kind of make you explore the network as the attacker would have to. So the attacker wouldn't have the direct button access to the router or the HMI or something. So we didn't want to give you buttons to directly access that from the dashboard. But you can find the documentation here to see all that. So that this is how the HMI is there, the router firewall is here, and all the different credentials, logins to access all that.
Nice. Okay. Cool. It's a good, very good for somebody who wants to learn. Really good, yeah. And like you said, does it require a lot of resources, computer resources, or?
Yeah. So with Docker, it's much easier, lighter weight. I think I don't remember if we mentioned that here in the GitHub or not. Maybe not. But if I remember correctly, I think it takes about 20 gigs of storage, and then memory. I think is only like 8 gigs or less. So yeah, it's all very, very lightweight.
All right. Eight is reasonable.
Yeah, and I don't remember. See if we can see what's being currently used. Oops, not that one.
And it could be run from Windows, Linux, Mac, you name it.
Yeah, whatever Docker, wherever you have Docker, it'll work.
Okay. Nice.
Let's see. So my current usage is only about 3 gigs. It looks like.
Okay.
So yeah, very yeah. So much less than 8 gigs even.
Nice. Okay, that's cool. Okay, are we done with it?
Yeah, I think so. I think that was the quick run through. There's kind of walk through of everything. Did you have any other questions on it or any requests?
Yeah, I mean, and you have the courses for it if they want to learn in a structured way. You have courses, right?
Yeah, so we do have one free course. If you go to learn.fortiphyd.com, we have a one free course currently that kind of walks you through how to set it up, and then walking through a few different exercises. So network scanning, so using Nmap to scan the network and find the Modbus devices, use the Modbus info script, intro to using Caldera. So using Caldera to do this network scan, to enumerate the devices, doing a simple man-in-the-middle attack, doing a simple command injection to send commands to the valves. And then it ends with a simple PLC programming exercise where you can you overwrite the PLC program, and if you do it correctly, you cause the reactor to blow up. So closing the valves to overpressurize the vessel, and then eventually it blows up.
So this applies to the lab version 3.
Correct. Yeah, we had an old course for the old version. We've disabled that. So currently, when you go there, go to the learn.fortiphyd.com page. It's only for the version 3 now. Yep.
Nice. And the paid version, they have more like content and.
Exactly. Yeah. So if you visit this webpage, you can scroll through and see all the other courses that we have. So not just focused on chemicals or Modbus. We have a bunch of other protocols in the different sectors and a bunch of other simulations.
And you have the maritime as well, of course.
Yeah. So that was the most recent ones. New ones were maritime focused. So we have a ship simulation and a port simulation. And then within that, we have like AIS protocols, which is what the kind of like GPS, but not really a different but AIS spoofing. So you can spoof locations of ships, like the Russian ghost fleets, spoofing locations of making ships look like they're different places or if they have different identities.
Yeah, very good. Excellent.
Yeah, and then our newest one that we're still wrapping up. It's not done yet. Our newest one is going to be on distributed energy resources, or DER. So that's we started working on it even before the Poland attack in December, but it turns out to be very relevant. So we're tweaking it to be more a little more like what happened in Poland, to help illustrate what happened in Poland when their DER resources were attacked. And so that one should be coming out hopefully in a couple weeks. It's taken a little bit longer to make those bigger tweaks to it, but yeah, so you'll be able to use attack DER specific protocols. So DMP3 is pretty popular in that, but there's some other ones as well. And you have solar panels and wind turbines, and seeing what physical impacts you can have on those.
Okay. And are you the guy responsible for the technical course, the material, or yourself or somebody else?
Mostly. It is a team, but most of the content, well, it's a mix. It just depends on what the subject is. But yeah, so a lot of it's me. Then it's the rest of our team as well.
Nice. All the team works in the same company, Fortiphyd, right? Or somebody?
Yeah, Fortiphyd Logic. Yep.
Fortiphyd. Why you call it Fortiphyd? What does it mean?
So it's the English word fortified is like strength.
Okay, yeah.
Strong, but we just
the spelling. Okay.
The spelling's different because it is all the domain names are taken and all the company names are taken. It's hard to find something unique. Yeah, when you really start to come up with names that have not been taken yet, it's hard. And it works for us too, because the PHY is like physical. So like we're dealing with cyber physical systems or physical operations. So
Fortified, like strength or something, huh?
Yeah.
Okay. All right. Interesting. So, are we done now, or shall we?
Yeah, I think so. Yeah, I think I can stop sharing if you don't have anything else specific around that.
Okay. So, I have a question. For the companies who want to use your lab, can they implement their own solutions and test them out? If they want to test, for example, Dragos or I don't know, Nozomi, whatever.
Yeah. So so with the default configuration for Docker, it's not that easy. It's actually easier with VMs because like you usually get a separate Dragos or Nozomi VM that you set up mirror ports for. We do have a separate version that we package together that you can do that. And people do use that. It's like already, especially with the older version 2 version. We heard tons of people setting up their own labs where they take out the pfSense router, they stick in a Palo Alto or a Fortinet firewall instead, and then they spin up a Nozomi or Dragos, whatever box to set up mirror ports to monitor the traffic and do it that way. So yeah, definitely something that people can do.
Okay, cool. Okay, so it's interesting to see open source OT labs. Why do you think they're becoming very important nowadays?
Yeah, I think it's a good sign that OT and ICS has finally been made it to mainstream. It used to be such a niche, rare topic that no one knew anything about, and so I think enough things have happened in the news, and enough companies have been successful now to put out a bunch of marketing. And Dragos puts out a ton of stuff for marketing that I think has helped to reach a lot of people. And so I think that's part of it. Is just it's finally hit mainstream, that people are more interested in it. They're looking for labs. They want to get into it because they've heard about it in the news. They've seen interesting things that different companies have put out for marketing. And so yeah, I think it's a great sign of new interest in the field, and also it's going back to that root problem of it's hard to get the hands-on experience with real devices. So going out, it's if you have budget, like buying things on eBay or used PLCs online is not too bad. But still, it's not everybody can afford that, and it's still a pain to set it all up.
So that's the limitations of traditional OT labs that prevented many people from experimenting.
Exactly. Yeah. Not everybody has, a few $1,000s just laying around to go out and buy a bunch of PLCs and network switches and set it all up. And then accessing just the knowledge and like instruction, like, okay, what do you do with that once you set it up? Like, how do you learn PLC programming? How do you learn to use PyModbus to send stuff or whatever other tools? It hasn't been very accessible until recently, and so it's
Okay, how do you answer to these people who say, "Oh, you are dealing with virtual. You're not. Are these skills transferable?" How would you answer this question?
I mean, Modbus is Modbus, whether it's a virtual network or a physical network. It's the same. It's the same packets that you're analyzing through the firewall or for the IDS tools. So yeah, I think that part is the same. And then like for ours, like what makes us, I think, a little special is that we have somewhat realistic physical process simulation going on as well. And so that's one other aspect of it, of like, okay, for some virtual labs, the physical realism is not really there. It's like very simplified. And if you're doing research or testing things that are more like a physical anomaly detection, the virtual labs most virtual labs may not be great, but I feel like we put in more effort on the physical accuracy side to still meet that need to make things accurate enough that you can still get that from the virtual testbed as you would from the physical testbed.
I think big companies like Siemens, maybe I'm sure you are aware of it. They are developing like virtual factories.
Yeah, I digital twins or
something like that, or like those glasses things that you can.
Yeah.
Do you think they could help, or they could be the future for training?
Yeah. I think they could. The limitation there, I think, is just how expensive that gets. If you get to be like really accurate, that takes a lot of effort. It takes a lot of very specialized knowledge and engineers to develop the highly accurate physical simulations of what's going on, and then to keep that updated as things change, as different different projects happen that update or change different parts of the process. Keeping the digital twin up to date can be a lot of time and maintenance as well. But it does come with a lot of benefits. So being able to run like a super accurate incident response exercise in a digital twin, that there's nothing better than the real thing, is being able to do it in that kind of realistic environment. So yeah, I think for the big companies, I think that's probably the way, the future. But I think for the small to medium sized companies, that's probably not within their budget, and they probably stick to more generic simulations or cyber ranges.
Okay. Are you trying to, like, for example, if you have pharmaceutical factory and they want to train their staff, how would they use your product? Or do you think there will be products soon for other industries, maybe?
So it depends. Like we have had some pharmaceutical companies just using our generic chemical simulation.
So there are common skills. There are common skills in.
Yeah. So intro to ICS security, basically training up basics of segmentation and insecure protocols and secure PLC programming. That transfers across, basically across all sectors. So there's some basic value from the generic simulations. Beyond that, we can build more detailed, advanced networks, and they more accurately represent both the physics of the pharmaceutical process and the different vendors. Like we've also done some projects where it is hardware in the loop. So we have our physical simulation that we built. We maybe have some virtualized PLCs, but we also deploy it in like a physical lab with like a real Siemens PLC or whatever real physical hardware that's plugged into the simulated network. So it's interacting with it just like it would in the real world. So that gets another level of realism potentially for those kinds of use cases.
Okay. Do you think, from your journey, is it challenging or very difficult to design the physical process simulations, and how do you make sure that they are mimic or somehow realistic?
Yeah. It's the hardest part is knowing the balance of how much realism is valuable, because you could never stop making it more accurate. Basically, you could always spend more time refining it and making it more accurate. And so the hard part is knowing when it's good enough, knowing when the simulation is good enough realism. And I think that's, yeah, as long as it feels real at a glance, just like looking at the process, looking at the HMI, as long as that it feels like a real process and doesn't obviously look too static or too predictable or something, that's usually good enough for most processes. Yeah, it depends on what the goals are of the training or the goal of the simulation is.
All right. And do you think you can offer, if somebody requested a specific simulation or physical simulation, do you think you can do this kind of service?
Yeah, we do. Yeah. So we do custom simulations.
Custom, yes.
Yep.
Interesting. Okay, I'm sure you've seen because you've been in the industry for a while now, for a long time, more than 10 years, maybe, I think. And what do you think of the OT security training? What are the limitations? What do you think a good training look like, in your opinion?
Yeah. So one of the biggest limitations is the reason we developed the open source project was the hands-on aspects of it. With a somewhat realistic physical process, and so that's why we developed that. Because most of the training out there, you may get like one little PLC that maybe it turns on some lights or something, and that's like, yeah, that's a nice maybe first intro to PLC, but that's the complexity of that compared to a real PLC process. It's just, they're so different. You miss out on a lot of just the mindset difference and the nuances of what goes into securing the PLC. So yeah, the realism of the hands-on aspects of it, I think is missing in most of the training out there today. And that's why we started the company, or it's the way I have the company to try to address that, making that more realistic hands-on part of the training.
So your goal when you started the company was training only. That's it.
No, sorry. It wasn't the main reason we started the company. We did actually originally started the company to commercialize both the training, but as also the intrusion detection technology that we developed. And so the training side of things just took off a lot faster than the IDS side of things. And so that's currently our main focus is just the training.
Yeah, I'm sure, because it's in demand, because so many people are joining and they are hungry for
exactly.
They find the courses a bit expensive sometimes in other
that's the other limitation. Some vendors offer courses for $10,000 or something for 5 days, and nobody can pay that out of pocket. Like maybe if your company has really good training funding, you can get paid. You can pay for it through the company, but for professionals, no one has that kind of money just sitting around to pay for training. and then the hands-on aspects of it. You maybe get a PCAP, you maybe get a tiny little PLC, not super realistic. So yeah, being able to offer things that the people can actually afford and that are practical with hands-on exercises is a big value add.
And you're trying to fill this gap, the cost and the realism, and
exactly.
The lab. All right. Do you think the cost is justifiable for those to charge this cost, this kind of money? Do you think this
$10,000 justifiable? I personally no. No offense to them, but no. You can. So my PhD is from Georgia Tech, and they created an online master's in cybersecurity program, and the price of that online master's from Georgia Tech, a well-known prestigious university, is less than that $10,000 5-day course from those other vendors.
Only 5 days. All right.
So yeah, so like an entire master's degree versus
5 days
versus a 5-day certificate. So yeah, I personally don't think it's worth that much. And we always complain about the need for more OT security professionals, or the need for higher skilled professionals, and then charging $10,000 for a 5-day course doesn't make sense to me. So
I think they have to justify it if the content is really, really maybe you cannot find anywhere else, maybe. But I haven't tried it, so I don't know. Okay. So what is the future of your lab? Do you think, what will you add in the, what do you think your test lab is missing that you need to add?
So for the open source version, let's see, we want to add a little bit more of the cyber hygiene examples, like the walking around, finding a few more things. We want to upgrade it to OpenPLC version 3, or into the version 4, the new version. And then the bigger piece that's missing, that we haven't decided the best way to do it yet, is more on the either like having like the Malcolm tool, which is like a CISA project, like something for SIEM, like incident response, or something more realistic for that defender side. Those tools can take up a lot of resources, is the challenge there. For Malcolm, the minimum requirements for Malcolm is like, I don't even know, like 16 gigs at least. And then that's just Malcolm, and then we have to have everything else around it. So yeah, we haven't decided the best way to do that, but we want to add something else for more of the defender side. So right now, like we had the basic firewall and basic IDS, but we don't have something more on the SIEM side. So we'll probably add something for that in the near future. And then on the paid side, we're always trying to cover more sectors, more protocols. Mentioned the DER simulations coming out soon. Eventually, we want to have like a satellite simulation, a car simulation. Basically anywhere where a computer is controlling something physical, we want to have a simulation to represent that, and to represent the types of protocols that are found there, and the types of concerns and vulnerabilities that you have in each of those niche areas of OT.
Okay, maybe IoT, maybe, or
like home automation, like smart locks and smart lights.
Nice.
Yeah.
Because there is a big trend as well in this direction, the IoTs and HVAC systems, and
yeah, exactly.
Interesting. Do you think maybe, because you said there is a challenge in implementing them, do you think if they are implemented in the cloud will solve this issue, or do you think there will be other issues if you host them in the cloud, Malcolm and others?
Yeah, so it's not easy. That's why no one else is doing it yet, obviously. It's like for some of that stuff, you have to simulate like the wireless protocols, and like completely virtualizing that is not that easy to do. Like there are tools like GNU Radio, like software defined radio. There's some simulation stuff there. That's one hard part of it. The other hard part of it is, even if it's not wireless protocols, there's not that many open source libraries for all these other protocols. We've been having to develop some stuff custom on our own. Like you have to find the specification for a protocol and then build a library for it ourselves to put it into the simulation. So there's definitely challenges, but it's all doable. It's all possible, and we're doing it.
Cool. I mean, I can see that you are doing your lab by trial and error and experimenting, which is I like the spirit. Do you think this kind of tasks requires maybe specialty, somebody who's good at designing technologies, or no need?
Yeah, I think if it's getting into the niche areas where there aren't existing library, like PyModBus, there's tons of Modbus libraries out there. So if you want to go build a Modbus lab yourself, that's not too hard. There's lots of resources out there to build Modbus labs. But once you get into the more niche, like maritime sector, there's different protocols, or even different vendors. Currently, we've been focused on the American markets because that's where we are. But then looking at like other markets, like the Asian markets, using Mitsubishi and Omron, like they have their own protocols that there aren't really good existing libraries out there that anybody can download and use, and so we've been having to build our own libraries for those protocols to be able to put them into the simulation. So all that to say, I think you have to have a good experience and mindset for working with network protocols to be building that level. There's those kinds of labs. And then, and it's like the research mindset of like, there's so many unknowns because no one has built a virtualized IoT lab or virtualized satellite cybersecurity lab. There's going to be a lot of experimentation as you figure out how to do it.
Do you think AI could help you generate this kind of code and technology? Yeah.
So we are starting to use more AI, carefully. We want to make sure it's accurate, not introducing, hallucinations and bad information and bad stuff. But it does, it has been saving us time developing, debugging things is the thing that's best at, or creating very small pieces of code that are just kind of tedious to do manually, but are very straightforward. It definitely speeds things up a bit.
Okay, interesting. Who is your course for? Is it for the IT, for the engineers, or for the managers? And what level? Beginners, intermediate?
Kind of all. So most of the content, we don't really assume much previous experience. So that means like most of the content is more beginner to intermediate. But we're creating new courses and targeting those higher level skills as well. So right now, mostly beginner to intermediate, both sides, IT and OT. And we do have some courses that are more for managers, but eventually we want to have something for everyone. Anyone related to OT, we want to be able to get them up to speed and get them more effective. And we're working on like learning paths for that. So both individual modules that are usually 1 to 2 hours each, but then we're creating like learning paths for different roles. So if you want to be like an incident responder for OT, we're trying to arrange our content and develop content. So take these series of courses to be an incident responder for OT. So that's still in development, not ready yet, but that's the plan.
I like that, to specify the path, the role, which is role path, incident responder, and teach him digital forensic and how to read logs, or choose a pen tester path, or SOC,
exactly.
or whatever. That would be interesting. I mean, this hack the box. They've done this now, and they have like the roles.
Yeah. Most of the other like
Yes.
online training, cybersecurity training platforms do something like this, but no one has done it specifically for OT. It's like they may have like OT, a couple OT courses.
That would be new thing if you've done it. Yes.
Yeah. So
choosing the path, and so you will be competing. Yeah, so you'll be competing with expensive courses that have paths, but
yeah,
because they do that as well.
Yep.
All righty, that's cool. What about if I want, see myself now, I want to arrange a CTF, and I want to use existed, I don't know, VMs or whatever. Do you think it's possible with you with your lab or?
Yeah. I mean, we actually hosted a CTF at the RSA conference in 2020, right before the pandemic hit, using version 2 of Grfics. So yeah, we definitely done it. So we use our lab setup, and then we used OpenCTF. I think that's what it's called. It's been a while since I've kind of forgot. But yeah, there's open source CTF tools out there like OpenCTF, I think, or CTFD. Maybe that's the name of it. I think it's called CTF. Yeah, but yeah, you can definitely do that. We've done it before, so yeah, it's definitely possible.
All right, cool. So before we wrap up, what is your daily routine? I mean, what do you do normally?
Oh man, that's a big question. I don't know. Yeah, so I guess for work, reading emails first, reading LinkedIn is probably right after that. If there's any immediate emails they need to respond to, try to do that. But then I've been trying to get better at both reading LinkedIn and then also posting on LinkedIn. It's been hard to keep up with that because it starts to take up a lot of time. That's probably the second thing to do. Always try to post something at like 10 a.m. is what the algorithm is supposed to like the most, I think. So trying to post something by 10 a.m. on LinkedIn. And then it really depends on the day, what projects we're focusing on, like what deadlines we have, if there's tech support issues that we have to jump in to help figure out, or just deep into the weeds of researching a new course, a new simulation, trying to develop something.
Is developing a course? Do you think developing a course is difficult, or?
In some ways, yeah. Like it always takes much longer than you think. And
at what phase? Like the designing the course or the filling the material, the contents? What is difficult?
A little bit of both. So, like deciding what should go in. So we've kind of been doing like, sector specific stuff, like a maritime course. Okay, so what should go into a intro to maritime security for a ship? So having to research, like what existing standards or regulations are there that relate to that. What existing incidents have happened in history. Like what all needs to go into a course on whatever sector we're doing or whatever topic we're doing. That can be hard to know how to scope it, because you can always go into more details, like what's the most important things for like an intro level course. Or what do people really want? What kinds of hands-on exercises would best illustrate different lessons? That can be kind of difficult. Not everything is easy to illustrate, or whatever, which then gets into like building out the content can be kind of hard. Of how do we build an exercise that illustrates the consequences of AIS spoofing or something like that, and filling that out with enough good relevant background information and other resources that to point people to if they want to learn more. That also takes time.
Okay, so but do you think sometimes when you design a course and you don't know how to implement it as a lab, do you think this could be a block sometimes, right? That makes you think, shall I proceed or not, right? Or...
yeah, so like we want to focus on what what people value the most, and so if they want to learn about maritime security and there's lessons in there that we need to teach, we're going to find a way to illustrate those lessons. Okay. It may not be, we may get stuck and not be able to do it the way we thought at first, and have to approach it a different way, but yeah, it's never been like completely blocked before.
So what do you think the future of OT security training will be in the future? Do you think we will just use AI and just forget about the training courses? What do you think the future will be?
Yeah, the whole AI aspect of it is difficult because like if you're just focused on Modbus or other popular things, AI is pretty good, but because there's so much, it's trained on whatever public content is out there, and there's lots of public content on Modbus or DMP3 or the most popular protocols. But when you get into the niche areas of the protocols that aren't so popular, that are more proprietary, the AI, in my experience, has not been as accurate. Like it hallucinates a lot more, and you have to be doing a lot more of your own research to fact checking it. So yeah, I think it helps, but I think I definitely think it will be a part of it. But in general, I think the future is going to be more and more realistic virtual like simulations of the networks, because we still aren't seeing that many real world attacks with physical impact. Like we know it's possible. It's definitely possible that attackers can do that, but we just aren't seeing that many examples of it in the real world. And so the only way to really prepare yourself is to do more realistic, like cyber range type exercises, or just at least more hands-on, realistic training to prepare yourself.
So this AI cannot take from you, like from us, the realistic simulation.
Yeah, I don't think it's. Yeah, I think. Yeah, to go beyond the basics, the AI is not enough. Like for just doing the basics, I think it may be okay. Because it's been able to train on so much public content. There's enough basic content out there that the AI is trained on that it knows that stuff pretty well. But going to the next level, going into more niche protocols or more niche sectors, or the more advanced OT specific stuff, the AI, that there hasn't been as much content out there for it to be trained on, and so it's not as good.
Yeah. So there's a hope for humans that they can beat AI in the niche areas and advanced areas. There's a hope.
Yeah, I think so. Yeah.
Yes. Great. Okay. Before we wrap, how would you advise now somebody who's beginner who wants to learn OT security? He has no background. How would he start? Whether using your lab or in a structured way, or your courses? How would you the roadmap?
That's a good question. So of course I have to plug our lab. So yeah, I think that is a great way to start. Yes. If they're more from the IT side and don't know anything about controls, I think one good thing to do is to watch. There used to be a show called How Stuff Works on Discovery Channel, where it would be like just videos of how it's made. I think, sorry, yeah, how it's made is the name of the show. And it'd be like videos of different factories of how different products are made. So like just being able to see like this is what a factory looks like that makes milk or milk cheese or just other random products. that kind of helps, just build the instinct around like how control systems work. And then there's good books out there, like Sandworm is a really good book to kind of goes into at a good basic level of a high profile attack and an APT that is very active in the OT space. Yeah, those are all kind of like cheap, easy ways to start building up the intuition of what OT security is about. It's about physical things, moving down the conveyor belt. It's about APTs that are interested in, nation state level goals, achieving nation state level goals, and then our lab, of course, like getting to see how a PLC interacts with the physical process and HMI and all that.
All right. Does he need to learn like the cybersecurity in general?
Yeah. So and then there's free cybersecurity resources too. So Try Hack Me has a free tier that some good stuff there to learn the basics. I think Hack the Box also has some free stuff. There's lots of good YouTube resources. Mike Holcomb, of course, is a great resource. Put out tons of stuff. People for beginners say, gotta suggest that as well.
Great. Well, thank you for joining us. Any last word you would like to say before we finish?
No. Thanks again for having me. It's been a great conversation.
Well, it's my pleasure, and thank you for joining us and sharing your information and your experience with us. It's been a pleasure. I know, we met 2 years ago, and it was supposed to be an episode, but we made it now. Thank you, and thanks to Basim for keeping up and arranging us again, because he's the man now. He's doing the pulling strings, and he's doing a really great job, Basim. Thank you, Basim.
Yeah. Thank you, Basim.
Yes. So, guys, this is it. I hope you enjoyed it, and hopefully we meet again for another episode. Bye-bye.